Good morning. My name is Manikant. Now I am going to say about implementation of space matrix manipulation. So this belongs to the course of data structures. So first of all, what is space matrix? A matrix in a two-dimensional data object made up of m rows and n rows, n columns, therefore having m by n values. If most of the elements of the matrix has values of 0, then that matrix is known as a space matrix. So this space matrix have maximum number of values in it as 0. So this is one of the simplest example that is shown on the screen. It has many number of zeros compared to the non-zero numbers. So then this is known as a space matrix. Why we use space matrix instead of simple matrix? For computing and for storage, it's one of the best and simplest and very powerful thing for storage. For storage, let us go through this. There are very less non-zero elements than zeros, and thus lesser memory can be used to store only those elements. So for storing data, we'll be storing in zeros and ones, right, in bits. So we'll be calculating, we'll be taking from this matrix only the important data that we have, that we are needed. So such as see here, there are only non-zero elements than zeros, and thus lesser the memory can be used to store only those elements. So the storing of the elements will be done in non-zero elements at maximum number of zeros. So since the zeros won't come into the counter, so that's the reason we'll be continuing with the non-zero elements. So to decrease the memory process, decrease the memory usage. So now going up onto the computing thing, computing time will be saved by logically designing a data structure transferring only non-zero elements. So this is one of the greatest thing that we can see here is space matrix. So the computing time will be decreased logically by creating a data structure for using only non-zero elements instead of zero elements. We'll be using only non-zero elements from this one, from this space matrix. We'll be using only non-zero elements to decrease the computing time, and it's one of the greatest useful thing for the space matrix upon comparing to this simple matrix. So there are mainly two types, two methods for representation of space matrix. Space matrix representation can be done in many ways, following two common representations. Two common representations, that is array representation and the linked list representation. First of all, let us go to the array representation. So the first method, array representation. 2D array is used for representing a space matrix. In order, there are three rows named like this. Row, column, and a value. So a row is named in this process, such as we will be described only a one single non-zero element for this three detailed things. So row is the index of a row in a space matrix where non-zero element is located. Similarly, column, it's the index of the column where non-zero element is located in the array, the space matrix. Value, the value of the non-zero element located in the index. At the index, column and row. So row and column, row comma column, that we will be usually seeing for the matrix. So this is the representation of the array. So this is the example for this one. So see this is a space matrix with n number of zeros in it. There is 3 is a non-zero number, 4 is a non-zero number, here 5 and here 7, 2 and 6. So there are very limited non-zero numbers here, and so that's the reason here it's known as a space matrix. So we'll be using this one to have a data allocation, that is, this is logically designed. So for this non-zero number, it has row of 0 and a column of 2. It's related to the second column, and it is related to the zeroth row. So this is the zeroth row, this is the first row, second row, third row. zeroth column, first column, second column, third column, and the fourth column. So this one helps for us in storage purpose. That is third row, sorry, third value. I mean this first non-zero value. This is 3 is a value here, and it is of belonging to the zeroth row. That is 0 is mentioned here, and the full column it's second column. Similarly, for this second non-zero element, that is 4, the value is 4 and its column is 4 and its row is 0th row. So the index of the row is 0, your column is 4 and your value is 4. Similarly, for this one, it is the row is first row and this is the second column and the value is 5. Similarly, and goes on with this using arrays technique. So now let us go to the linked list technique, which is one of the easiest thing that we can access. In linked list, each node has 4 fields. These 4 fields are defined in such a way that we will having 3 will be using for row column value. When the fourth one is for the next node, the address of the next node. So see this, the row, similarly as we have said in the array allocation. See this one, arrays technique. So from the matrix, we will be collecting the index of the non-zeroth element and also column of the non-zeroth element, so the index of the column where non-zero element is located, that is column, and the value of the non-zero element located at that index, that is row comma column. So then after the next node, that is address of the next node. Let us see how we will be dealing with it. So this is the one. This is considered this as a Sparse matrix. So this is a Sparse matrix with which are taken before in the first method. So see this. This is the process. Starting with the first non-zero element, that is 3. The value is stored here, and as it is stored in the process of row, column, value, and the next node. That's the address of the next node. So this is a location process. So this is first row, this is the first node and having the 0th row and the second column, and the value of this one is 3, and the next it has a address of the next value, that is the next. This is the fourth, this is the second 0th element, non-zeroth element in this array. So it consists of that address, that is next goes through this one, and that is 0 is a row, index of the row, and the fourth is the index of the column, and the 4 is the value of that one, and then after it stores the next address of the next non-zeroth element in that Sparse matrix. So the next non-zeroth value is 5. So value is noted here, and its respective row is 1. Index of the respective node is 1, and the index of the respective column is 2, and the value is 5, and it also has another column that is used for storing the next address of the next node. So thereafter it goes on like this. So the main thing we must note here is the node structure. That is, first it consists of node, the first field consists of node, second field consists of column, third field consists of value, and the fourth field consists of address of the next node. Thank you so much.